And so here we are looking at simplifying radicals with variables that are not perfect square roots. And we talked about expanding the x's all the way out, and with the square root we're looking for groups of 2. So these two x's came out once. So we ended up with x to the 4th outside and this extra x on the inside. We're not going to write all these x's out every time we do them, so there is some of a shortcut method that you will see in MATLAB as well. What we're looking at is, if we write this in exponent form, it would be x to the 9 divided by 2, the index here. 9 doesn't divide by 2 evenly. So we're going to split this apart into two separate variables so that one of them does divide evenly by 2. So if we back down one exponent from the 9, we'd have x to the 8th. And x to the 8th we can divide by 2. So here I split x to the 9th into x to the 8th times x, which is equivalent to x to the 9th. This x to the 8th can divide evenly by groups of 2. So this x to the 8th will come out as x to the 4th. So here the x to the 8th on the inside divides by the 2, so it comes out as x to the 4th. And the extra x is left on the inside, just like we got here. So this is the basic concept of simplifying the variables. We're going to have to do them with third roots as well, and with constants inside too. So here's the other example in the notes, number 3. So this is number 3 in the packet, but this other problem was, it was number 2 in your note packet. So on number 3 we have two variables, and the a to the 10th is a perfect square root because we can do even groups of 2. So 10 divided by 2, this will come out as a to the 5th. B to the 15th is not a perfect square root, so we're going to split that apart. We're going to go down to b to the 14th times b. So here I kept a to the 10th because it can divide by the 2, and took b to the 15th and broke it down to b to the 14th times b. So these first two will come out as perfect squares, and the extra b will be left inside. So here a to the 10th divided by the 2 is a to the 5th. B to the 14th divided by the 2 is b to the 7th. So these two come outside, and this stays inside. So here's what your answer looks like. We're going to do the same idea with a third root problem next. So number 4 on the handout, now we're dealing with the third root. So if we were to write all 11 a's out, which we could do, we're looking to circle groups of 3. So how many groups of 3 are in 11? We will have 3, 6, 9. So we will have 3 groups, so that's a to the 3rd, and then there's going to be 2 leftover a's on the inside. So this we're going to break down. B to the 15th divided by 3, we'll have an even group of b to the 5th outside. So here I used a to the 9th because if I go down one at a time on this, we would have a to the 10th, and the 10th will not do even groups of 3. So we go down one more, so a to the 9th, we can do the even groups of 3, and then we have 2 left over because the 9 plus 2 gives 11. And b to the 15th is all good, so we don't need to break that apart. So our a to the 9th with groups of 3 comes out as a to the 3rd. This will stay, and then b to the 15th is going to come out. B to the 15th with groups of 3 will be b to the 5th. So there's our b to the 5th. So these two go outside, and the extra a to the 2nd stays inside. So here's a to the 3rd, b to the 5th, and the extra a squared inside. And don't forget the 3 in your index right there. So here's number 5. It's a combination of variables and a constant underneath the radical. So we're bringing it all together in one problem. we're going to have to break down the 75 because it's not a perfect square root. A to the 7th is not a perfect square root, so we're going to separate that. B to the 13th, we can't take even groups of 2, so we're going to separate that. C squared is a perfect square root for a variable, so we don't need to worry about that one. So this is what all of this is going to do to help us simplify. 75 is 25 times 3. A to the 7th, we back down by 1 to get our A to the 6th to get even groups of 2. And then the extra A. So A to the 6th times A gives us A to the 7th. B to the 13th, we're coming down to B to the 12th. And then the extra B. C squared we're keeping. So the square root of 25 comes out as a 5. The A to the 6th, we're looking for groups of 2, so the 6 divided by our index of 2 is A to the 3rd. B to the 12th is going to come out as B to the 6th. And square root of C squared comes out as a plain C. So here's our answer. All the perfect square roots came out and the extra parts stayed inside. For a square root, you should never have an exponent in here, because if you have an exponent of 2 or higher, it should have simplified out farther. So I need to at least see for the 75 that you wrote a 25 times 3, but this variable up here, some of you can just figure it out in your head. A to the 7th, you're looking for groups of 2, so that gives you 3 groups. That's A to the 3rd, and the extra A stays inside. B to the 13th, groups of 2 would be 6 groups, so B to the 6th with the extra B on the inside, and then the C squared, of course, comes out as C. So I'm going to skip ahead and look at number 8 in your note packet, a third root problem with a constant and variables. So we need to figure out our factors for 120h so that one of them is a perfect cube. It's going to be 64 times 2, and it'll take some of you some time to remember how to figure that out, but we've worked on it. So we can break down our 128. A to the 11th, we're looking for groups of 3. There aren't an even group of 3. So if we show our work here, we're going to take the 11 down to, we can't go to 10 because we can't make that groups of 3. We're going to go down to 9. So here we have 64 times 2 because 64 is a perfect cube root number. 4 times 4 times 4. And I used A to the 9th times A to the 2nd, which gives us A to the 11th, but this shows that the 9 A's we can do groups of 3. And then B to the 3rd can just stay because we have an even group of 3. So our 64 is a perfect cube. It's going to come out as 4. The A to the 9th is a perfect cube. We can do groups of 3. So that's A to the 3rd. And the B to the 3rd. So our A to the 9th came out as A to the 3rd, and then B to the 3rd is a perfect cube. We have one group of 3. So the top are all the parts that come out front, and the 2A squared stay inside. So 4A to the 3rd B, and then make sure you have the 3 in the index, third root of 2A squared. I did just notice that on the handout there was a negative out front of this whole problem. So we do need to come up to the original and throw the negative in front. So that negative just stays out front of the whole problem.